Stretches. Objective by end this lesson, you should be able to graph functions using stretches, apply stretches to given points to find unicorn. A stretch can also be called a dilation, and in this lesson we're going to talk about how to do a stretch horizontally and both vertically. So, stretches are multiplications of our function. So if you remember from the last lesson, our general function kind of looks like this. And then when we did a translation, it was x minus h plus k. Right? These are adding and subtracting, those are translations. Stretches are multiplications, so you'll see something more like akin to this. A f of bx, like that. It's the same idea though. A is on the outside, and it's outside y follow. So you can think about it as multiplying your y values by A, right? B is on the inside. Inside affects the x values, and you do the opposite operation. The reason I say opposite operation because you're not going to multiply your x values by b, you're going to divide by b, or also known as multiply by the reciprocal. So we're going to multiply x values by 1 over b, also known as dividing by b. It's on the inside, and inside you do the opposite operation. That's how it works. And that's the general, and we're going to do more of that, but that's the general idea, right? Outside always affects the y values, and you follow what it says. So if it says multiply, you multiply. If it says add, you add. Inside affects the x values, and you do the opposite operations. If it says minus, you add. If it says multiply, you divide, or multiply by the reciprocal. And that's the way this works. So if you see this example here, they start off with x squared. Here's our x squared graph in black. And then they want to graph 4x squared. Well, again, that's going to affect your y values, so you multiply all your y values by 4. So if you look at the point right here, now this is very zoomed in, but the point will be made. So you look at this point right here, right? So that's on x squared, and we want to graph 4x squared. So we're going to multiply our y values by 4. You get this point, you multiply by 4, and you get the point right here. Right? This height is 1/4 of the total height, so you multiply by 4, you get that one. So it works. And if you look at it in this way, this method, f of 2x, or I guess in this case, you get your normal x squared graph. Let's look at the point right here, the point 1, 1. And what's this graph telling me to do? Well, it's telling me to divide my x value by 2. It's on the inside. So we're going to divide our x value by 2. So you have the point 1, 1. And you divide your x value by 2, multiply by 1/2. Let's say multiply by 1/2. Let's keep it consistent. So I get 1/2 and 1, which is the point 1/2 and 1. So it works that way also. And then if you just do the math on it, right? So you have a 2x on the inside, you square both of them, and you get 4x squared. These are the same thing. That's why you get the same point either way. And we'll talk about that, how a vertical stretch and a horizontal shrink are the same thing. But that's the way this works. You follow the same rules we do with translations, but we apply it to stretches. So anything on the inside affects the x values, and you do the opposite operation. Anything on the outside affects the y values, and you follow the operation. So let's look at an example here. Consider the graph of fx along the side. On separate axes, draw the graph of 3f of x and y equals f of 2x. So again, I think it's helpful if we use points. So I'm going to hit some key points here. This is -4 and 0. So -4 and 0. Let's look at this point. That'd be -2 and -2. Let's look at 0, 0 is a good one. Let's do 0, 0. We'll do it over here. I'm going to add space. Okay, and then let's do this point right here. That is 2, 1. And finally, we'll do the point right there, 4, 0. So those are 4 key points I wanted to use to make my graph. And let's do this one. Y equals 3 f of x. Notice that 3 is on the outside, so I'm going to multiply my y values. I like to show this. So my y, I'm going to multiply by 3. And we're going to multiply y values by 3. So in a way, think about it, you can stretch it by 3. So how does it look when I stretch this by 3? Like this gets multiplied by 3, that gets multiplied by 3. Stretches for me are always hard to do, like visually. Like shifts I could kind of do, but stretches I have a harder time with. I just follow the mathematics. This tells me to multiply my y values by 3. So if I'm doing that here, multiply all your y values by 3. You're going to get the point -4, 0, -2, -6, 0, 0, 2, 3, and 4, 0. So let's plot those points on this graph here. So -4, 0, same spot. Then I get the point -2, -6. So here's -2, -6. Actually falls off my grid. This is 4, 4, 5, 6. And then we have the point 0, 0. So that point doesn't change. And then we have the point 2, 3. So 2, and then we go up to 3. And we have the point 4, 0. So a graph that looks like this. Right? And you hope you can see, like, it's this graph, but get all the key points and multiply by 3 on your y. So it's a vertical stretch of 3. This is the next one. So we'll do the next one purple. Let me erase these. I need the space. Okay, so the next one, f of 2x. Now notice the 2's on the inside. And remember, inside, x opposite. So doing red. Opposite operation. So instead of multiplying my x by 2, I'm going to divide by 2. Or I'd like to say multiply the reciprocal. So we're going to multiply our x's by 1/2, right? So the opposite operation. So we're going to get here, we're going to get all our x values, we're going to multiply by 1/2. And I get -2, 0, -1, 0, 0, 0, 1, 1, and 2, 0. So there we go, right? Again, inside x opposite operation, so I'm going to multiply our x values by 1/2. If we plot those points, -2, 0, -1, 0, -1, -2, sorry. -1, -2. And then 0, 0 stays the same. And then 1, 1, and then 2, 0. You get a graph that looks like this. Right, so it got shrunk horizontally by a factor of 2. So that's what happened. So it all got shrunk in. So that's how I do a horizontal shrink and stretch. Let's look at this one. What is write g of x in terms of s? So here's f of x. What did g of x do? How do you go from here to there? Well, to me it looks like this is a point 0, -1. And now we have the point 0, -3. Sorry, -2. So it looks like we multiplied by a factor of 2. So I would say g of x equals 2 times f of x. Right, if you got your points and you times it by 2, you should get this point. It's probably the easiest one to tell. But you look here, we're at -3 and then we go to -6. So it looks like g of x is just 2 times f of x. Okay, so we did this last time. Suppose f and g are functions such that g equals f of x. I want to know what this function is, what this point turns into. So if we plug this into the thing, what does this do to that point? Well, again, what does this do? It's on the inside, it's the x. So we're going to do the opposite operation. Right? So instead of multiplying by 5 on my x's, I'm going to multiply by 1/5. That's all it wants to do. So we get a point here, we're going to multiply our x value by 1/5. And we get -2/5, 1. And that's it. Next one. There's 2 things on this one. Notice how there's an x and a y. So let's keep them separate. What happens on my x and what happens on my y? Well, my x, right? Inside opposite, do the opposite. We're not going to multiply 2, we're going to multiply by 1/2 or divide by 2. On my x, I'm doing that. On my y, outside y, follow what it tells us to do. So we're going to multiply our y values by 3. So that's all I'm going to do to these points. On my x, I'm going to multiply 1/2. On my y, I'm going to multiply by 3. So I get this point here of 1 and 3. That's my new point. Over here, we're going to do the same thing. We're going to multiply x's by 1/2, and we're going to multiply our y's by 3. We get the point 1/2 and 18. So those are the new points based on what this thing does to my g. Those are the new points of g based on that. So that's the idea. So let's do one more. The function g of x results when y equals 1 over x is transformed by the vertical stretch and scale factor of 2, followed by a translation of 3 over -2. Okay, so kind of putting everything together. So vertical stretch and scale factor of 2. Keep in mind it's a vertical stretch, right? So what does that mean? We're going to multiply our function on the outside by 2. So here's our function. We're just going to multiply it by 2. So we're going to get 1 over x, and we're just going to multiply that thing by 2. That's going to give us y equals 2 over x. 2 over 1 if it helps. So that's the scale factor. The vertical stretch with a scale factor of 2. That's all that says. Right? It's a vertical stretch, so it's on the outside, and telling us what the scale factor is too. So I get that. Followed by a translation of this. Remember how this vector translation means? All it means is the top is your x movement and the bottom is your y movement. That's all it means. Now how does that factor into this? Remember, x is inside opposite. And again, it's a translation. It's not a stretch. It's a translation. So instead of adding 3, we're going to subtract 3. So that is this. Right? X inside opposite. And your y is outside follow. So we're going to add 2 to the outside. Subtract 2 from the outside, sorry. Outside follow. And that's our equation. So that's A. So that's the first part. And then, let's see, B wants to write expression for g of x in terms of this. So they just want to write this as a fraction. So that's just a review of how to add two fractions together. So let's look at A here. If we want to add these two fractions together, how do I do it? Well, common denominator. This is over 1, so we'll multiply by x minus 3 and x minus 3. So we get distribute the negative. So 2 plus. Why is it a plus and not a negative? I'm going to distribute the negative with the 2 to make it easier. So I'm putting this together. So minus 2x plus 6 over x minus 3 over x minus 3. When you add them up, you just add up like terms on top here because it's the same base. So I can add this guy with this guy. And I get negative 2x plus 8 over x minus 3. So that is our function g of x. Alright, so that's our function g of x, right? So again, first I use a translation to make my own equation, right? Vertical scale factor of 2, so you multiply this guy by 2. And then translations, that's what we did last lesson, right? So this affects my x, this affects my y. Inside opposite, outside follow. Find the asymptotes of y equals g of x. Well, if I want the asymptotes, a little review here, horizontal asymptote, right? Powers. What power is bigger? In this case, they're the same, so you take the ratio, negative 2 over 1. So y equals negative 2. By the way, if we would look at it like this, what would the asymptote be here? Well, you say bottom is bigger than top, so 0, but then there's a negative 2 on the side, so it'll still be y equals negative 2. Vertical asymptote, you said the denominator equal to 0. So in this case, x minus 3 equals 0, so I get x equals 3. Now if they want me to graph this, I think that's the next thing, to sketch a graph of this. So remember the way we start the graph? Start with the asymptotes. So here's my x, here's my y. Start with the asymptotes. So x equals 3, dot, 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 dot. Y equals negative 2, 1, 2, dot, 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 dot. Now, if my graphs are off like this, you could use your calculator to fill in the values, or you can make test points, right? You can put a point over here, see if it's top or bottom, put a point over here, top or bottom, find the x or y intercepts, see where it fits that way. But if we look at this one, when we talk about this one, if it's a positive, it starts on the top right, because this is a basic reciprocal function. So it starts on the top right, and then bottom left. So that's what the graphs look like here. So something like this, and like this. Again, if you don't like that, feel free to double check on your calculator or find the x and y intercepts, and that'll get you the values too. That's this lesson.